All right. Get the camera right there. Okay. So, Math 4 people, let's go through a speed quiz here. I'm going to basically kind of tell you a little bit my thinking, showcase what I mean by more than one answer, as well as in some of these cases, build questions backwards. So, like if you see something like this on the quiz, you're a little more prepared for that. So, I pulled up, what is it? Speed quiz number 4 here. So basically, just work, and again, you don't have this one. You have 1, 2, and 3 in a mega. If you need more, let me know. But I don't know how many people have gone through that many. Just look at the first question here, okay? Cotangent of theta is negative square root of 3. And this bit here, this 0 less than or equal to theta less than 2 pi, just means in one full revolution, when does that happen, okay? So we're starting off with a cotangent, all right? We had, let me go ahead and write this out. Cotangent of theta was equal to, I want to say negative square root of 3. Yep. So I don't think cotangent stuff very well. I like to basically turn this into tangent, which is the reciprocal. And what that means by reciprocal is I'm going to take this fraction and I'm going to flip it around. I'm going to flip it upside down. This is currently a root 3 over 1, so it's going to turn into a negative 1 over root 3. Now, everything we're going to give you is going to be from the unit circle. So what I need to do with this to make this match a form that might look a little more familiar, come along and multiply your root 3 over root 3. This is a test you should probably have a pencil and paper for. It's more than other ones. Don't try and fake your way through it. Basically, that's going to give me a negative root 3 over 3. So the question of when is cotangent of theta negative square root 3? It's whenever tangent of theta is equal to a negative root 3 over 3. The times these happen are the exact same. The reason I switch, let's get some lines here, is I know my quadrant 1 stuff pretty well, and the rest of it I can start to reason out. So let's pick a different color. I'm going to do all these different pi over 4s in these blues, and then we'll do pi over 6s in this purple. And then let's do sort of a maroon. Now we'll do just red. Cornhusker red there for our pi over 3s, okay? The tangent ones that are worth learning are at least these 3, okay? I'm going to go ahead and give you a tangent of 0 radians is going to be 0. Tangent at pi over 2 is undefined. I'm not going to label all these for space, as well as we've done so much with the unit circle, we should have a good idea what these angles are. This coordinate point right here at pi over 4 is root 2 over 2, root 2 over 2. It's the same x and y value. So if you ask for tangent, which is y over x, and you divide the same thing, what are you going to get? 1. Tangent, that means now at any of these pi over 4s is going to be a 1 or maybe a negative 1, depending on some of this stuff. So at pi over 4, tangent is 1. At 3 pi over 4, that's going to be a negative 1. Right, because with tangent negative here, I have a positive y but a negative x. If I were to go to quadrant 3, tangent is going to be positive now because I have 2 negatives, so it's going to be a positive 1 here. And it's going to flip back to a negative 1 in these 2 quadrants. Basically, the mirrored quadrants, the ones opposite each other for tangent, are always going to be the same. And I'm going through this now. I have a lot of this sort of stuff in my head, or this is the process that I'm going through just to kind of train you on that sort of thinking. Let's do the this pi over 6 guy next. This coordinate point is root 3 over 2 half. So if I do y divided by x, that's going to give me 1/2 divided by root 3 over 2. I'm going to change that into 2 over a root 3. Those guys are going to cross cancel. We're going to get 1 over root 3, which we just saw the math right up here. That really turns into root 3 over 3. There we go. So if I have a pi over 6 angle, one of the unreduced ones, the tangent value there is root 3 over 3. So what does that mean? Where's my lines? If I were to go to 5 pi over 6, tangent in this quadrant is negative, so that's going to be a negative root 3 over 3. If I were to go to 7 pi over 6, we've gone back to positive now, so that's going to be a positive root 3 over 3. And then 11 pi over 6 is also going to be another negative. So I can take this guy, basically copy this, copy it here, and I'm going to put negatives on the ones here. Oops, didn't want that one. So I know only quadrant 1 through reflection, I can get the rest of these pieces here. Now, that's enough to basically help us figure out sort of our answer. We're going to come back to that, though, just to finish out this last one. The same math that I did right here, if you flipped it so it was root 3 over 2 divided by half, again, you can walk through that on your own. Basically, what you're going to find is that this value right here, I'll go ahead and change it to red to make it stand out a little more. Tangent at pi over 3 is going to be a root 3. So if I put in these other lines, at 2 pi over 3, this is going to be 4 pi over 3, 5 pi over 3. I'm going to get a negative root 3 here, because again, you'll notice that tangent is always going to be negative here. It's going to be positive in quadrant 3, so I'm just going to get a regular root 3. And then back in quadrant 4, it's now a negative root 3. What works for my brain is tangent is y divided by x. I'm going to draw one other color here, but I'll get rid of it in a second. If I go to pi over 6, the y value right here is that little half. Whereas if I go to pi over 3, the y value right here is root 3 over 2. It's a much bigger y value. You can see it visually. Well, if I'm doing y and I'm dividing by x, this is a small y getting divided by a big x, whereas this pi over 6 is a big y divided by a small x. They start with the same number, a root 3, but this one's divided by 3, which makes sense. It's getting divided by a bigger number. So that's how I've learned these tangent things. Once I know them, again, you don't have to do this all sort of on the test. If you know these values, you probably had this done in 15 seconds. We turn it into tangent. We're asking, when is tangent equal to negative square root of 3? We think, oh, that's a small y, big X. It's a pi over 6 angle, but it's negative, so I'm really going to need 5 pi over 6 and 11 pi over 6. Those are your two answers. The question's asking, when is cotangent equal to negative root 3 over 3? That's true when when cotangent is negative root 3. That's equal to when tangent is negative root 3 over 3, and here's that process. You don't have to do all that every time. I don't imagine you will. If you memorize this sort of thing right here, you can use that to fill out the rest of them. So next up, and you'd have to do a multiple selection for this. I'm just going to skip the sake of time. What do we have? Secant here is negative 2 root 3 over 3. So we have secant theta was negative 2 root 3 over 3. I'm going to flip this one because I don't know secants very well. I'm going to turn this into, secant pairs up with cosine. And if I flip this fraction right now, that's going to look like this. Negative 3 over 2 root 3. Now, if we clean this up, the way we do that is we're going to multiply by a root 3 over a root 3. Right here, this root 3 times root 3 is going to be root 9, or 3. It's going to cross-cancel with this guy, so what does this whole thing really turn out to be? Negative root 3 over 2, which you should recognize as a known unit circle value. When does that happen? Do you know when cosine is going to get this? Well, I'm asking when's cosine negative. I'm looking for probably two answers here. It's going to be negative in quadrants 2 and 3. I'm looking for a big x value, but negative, so it's really going to be this guy right here. That's how I'm going to get a 5 pi over 6 and a 7 pi over 6. You're going to need both answers. When is secant of theta equal to negative 2 root 3 over 3? It's when cosine is a negative root 3 over 2. I like to turn them into this other form. If you know your reciprocal unit circle super well, great. This is probably the easiest test for you. I don't. Let's jump to 3. When is secant of theta root 2? So I've got secant of theta, and I'm asking when it's equal to root 2. Same thing, I'm going to flip this guy. The reciprocal of this is going to be cos of theta. So this is now going to be 1 over root 2. basically the way this guy, we're going to multiply by root 2 over root 2. What it really does is it moves the root up top and leaves the number without the root in the bottom. When is cosine? First off, it's positive. I'm looking for quadrants 1 and 4 because I'm talking about an x value. When is it root 2 over 2? Pi over 4, 7 pi over 4. You'll notice that the x value, this length right here, is exactly the same. Be aware, we're going to expect multiple answers for a lot of these. 4. Cotangent is a root 3 over 3. So with tangent and cotangents, when are they positive? I'm already thinking quadrants 1 and quadrants 3. Some Roman numerals over here. If I flip this, this guy's going to turn into tangent. That's the reciprocal. And if I flip this around, I would get 3 over root 3. I'm just flipping that guy. Let's clean this up. So I'm going to basically get, it's going to turn into 3 root 3 over 3. And then those are going to cross cancel, so I get just square root of 3. When is tangent equal to square root of 3? That's one of the ones we just talked about, those big y values. So it's going to be this guy right here, which is pi over 3, and then that same angle basically in quadrant 3, 4 pi over 3. That's why you got to know those tangent ones to basically make the rest of this stuff go way quicker. I got my quadrant 1 and my quadrant 3. I need to be able to use these two reference angles to go from here. Oops. All right, when is secant of theta equal to -2? So we're getting a lot of the reciprocals, which is good, because this is going to basically, if we give you a sine, cosine, or a tangent, we already want you to know those. The reciprocal ones are going to make you think a little bit, but we have secant of theta is a -2. Let's flip it. The reciprocal of secant is going to be cosine. The reciprocal of -2 is going to be -1/2. Cosine is negative in quadrants 2 and 3. That's where my answers are. I'm not messing with the Roman numerals. It's a small x value, so I'm talking about this guy right here. That's 2 pi over 3 and 4 pi over 3. This is the process. This is what goes through my head when I'm doing these sort of things. Let's pick a few more and then talk about some algebra for this. Okay, so we'll take this guy right here. It's asking, when is secant of theta 1/2? So I'm going to do some algebra to this to show how I would build maybe one of the test questions that makes you do a little bit of algebra that isolate the trig. Then we'll actually get back to solving this, okay? So let's go ahead and copy this guy. This is where we sort of started with. Change its color. Let's say I came along and I wanted to get rid of that fraction. If I doubled both sides, that would now turn into 2 secant of theta equals 1, right? I'm multiplying both sides by 2. If I now, let's say, subtracted 3 from both sides, I would get something maybe looks like this. 2 secant of theta equals -2. And there's a couple ways. Ooh, sorry, I'm missing something there. I did not do that right, or I just ignored that over here. I would get 2 secant theta minus 3, because I know algebra, is going to equal to -2. If I gave you this test question, and we asked the same thing, so it would say, solve 2 secant theta minus 3 is -2 for 0 is less than or equal to theta is less than 2 pi. It's saying, give me all the times where that equation is going to be true. What we're going to do is first you're going to try and isolate this guy. So consider your middle school algebra that you're going to do. I'm going to go and I'm going to add a 3 to both sides. That's going to give me a 1 right here, and I'm going to get 2 secant of theta. I'm trying to isolate the trig. It's being multiplied, so if I divide both sides by 2, I get back to secant theta is 1/2. Right? We're going to take nice, pretty things like this and then just add a little bit of algebra to them to make some of those test questions. Now, let's analyze this piece, okay? The reciprocal of secant is going to be cosine. And the reciprocal of 1/2 is 2. So we're asking, where is cosine equal to 2? this one is intentionally tricky. Doesn't happen, right? The highest cosine ever gets is all the way right here. That's 1. The lowest that ever gets is all the way over here. That's a -1. Cosine's never going to hit 2. Right? If you even drew a graph of cosine, one of these guys, your cosine's going to go from 1, here's your -1. It's going to be one of these things, right? It's never going to go outside of that range. If we're asking the question, when does it hit 2? Doesn't happen. So we could basically give you a little bit of algebra, expect you to isolate the trig, then analyze when is secant of theta going to equal half? It doesn't. The reason that, if we were to draw that secant graph to get a little more information, secant's going to look like this. This is going to be really a top tier drawing. There's going to be some asymptotes and stuff, but basically you get it. Oh no, I put that way too high. Where if I were to take, actually, hold on, I can do this kind of clever. We'll just do it the easy way. That's where 1 is. That's where -1 is. -1/2 is going to be right here. Is that graph ever going to hit it? Not going to happen. Kind of like a little frowny face if you look at the eyes right there. Right? There's the mouth, there's the eyes. Anyhow. So let's do a few more, and then that's sort of the thought process. Let's see if we can find a good one. 7. Cosecant of theta is 1. Sure, why not? When is cosecant? Oh goodness, that's not the marker I want. Cosecant of theta equal to 1. Reciprocal of cosecant is going to be sine. The reciprocal of 1, you take 1 over this, flip it upside down, you're going to get, it's 1. This is one that only has one answer. Pretty much everything we've done so far, ignoring the previous no solution, like it didn't happen, and I'll show you. There is a no solutions option for a lot of these things. This one only has one answer. We're asking, when does the y value hit 1? It's right here where it hits 1. Down here would be a -1. That's not what we're asking for. We're asking when cosecant is 1, which is the same as when is sine equal to 1. There's only one time. Pi over 2. That's it. Be aware. Don't just necessarily assume there has to be 2 answers and go with it. We're going to throw a mix of these at you on the quiz. I know because I've taken it. Be aware with that. Let's see. Is there a way to skip at the bottom, I think? Yeah, there is. Cosecant of theta is -2. We just did that same sort of thing. It's basically going to be when is sine equal to -1/2, right? That's the same deal. When is sine equal to -1/2? Negative in quadrants 3 and 4. It's going to be your 7 pi over 6, 11 pi over 6. That's the thought process that goes through my head. Another tangent one, basically the same thing as that first problem. This is the √3 divided by 3, so I'm thinking it's the small one, so it's like the small y value. It's negative, so it's quadrants 2 and 4. When is it that value? That same piece, what I mean in quadrants 2 and 4, it's going to look like this. It would be small y value, small y value. So that's going to be 5 pi over 6, 11 pi over 6. I can do this super quick by just sketching one of these. Have a piece of paper, draw a quick thing like this, label your parts. The quiz, no problem at all. Let's finish it out. Why not? When is tangent equal to 1? There's 2 places. When is tangent equal to 1? Well, we kind of already established those in that first slide. Positive in 2 different quadrants. Tangent being 1 can happen twice. Remember, because the period of tangent is pi, not 2 pi. We got pi over 4. 5 pi over 4. There you go. 11. When is cosine equal to 2? Think about what we just said a couple slides ago. It doesn't happen. Cosine can only go between 1 and -1. What's your answer for this guy? No solutions. I guess I haven't been marking the previous answer, so I'm going to get a 1 out of 15. That's not great. When is cos equal to √3 over 2? Come on. I'm looking for positive x values, and they need to be big, so it's these 2 angles right here. That's going to be pi over 6, 11 pi over 6. Pardon the alt tab. When is cosine equal to √2 over 2? Same 2 quadrants, but now it's pi over 4, 7 pi over 4. You got to know the unit circle, understand the symmetry of it, and then you're going to get 2 answers for a lot, but not exclusively. When is sine equal to root 3 over 2? I'm looking for a positive y value, which is quadrants 1 and 2. It's a big y, so it's going to be this angle right here. That's going to be a pi over 3 and 2 pi over 3. And for the last one, build a test question out of this. Yeah, okay, sure. When is sine of theta equal to negative half? Okay? A question that we might build for this. Oops, wrong slide. When is sine of theta equal to negative half? That does happen. The answers, we're looking for negative y values, and it's a small one. It would be these two right here. Because my y value is this guy. Yeah, I didn't maybe quite get the half, but you get the point. It's going to be 7 pi over 6 and 11 pi over 6. Those are the answers that I'm looking for. I could ask a question that would get me these. I'm thinking, oh, it's the same y value. I might turn this into a reciprocal. Say, oh, okay, hold on. Let's trick it up a little bit. I'm going to make this cosecant of theta. The reciprocal of negative 1/2 is going to be a negative 2. Let's triple it. So now we have 3 cosecant of theta is going to equal a negative 6. And I'm going to add that 6 over. 3 cosecant of theta, plus 6 is 0. I ask you to solve this question. I ask, when does that happen? It all started in the main, you're going to do a little bit of middle school math to get to this stage. Then you're going to do some math 4 to get to this stage. You're going to use what you know from your unit circle, which is math 4, to answer that. So it's half middle school math, it's half math 4. What you're going to see next week is the same thing, except there's going to be a little bit funkier stuff here with this angle. So you're going to do basically middle school math, then math 4, then more middle school math. That's all I got for you for now. A little bit of rationale on sort of the thinking, how we can build test questions, where it sort of starts from, and what sort of things you're going to kind of see. It's Wednesday, the 6th, so that worksheet is due tonight, and I'll upload those answers for the worksheet tomorrow. Quizzes is due Thursday at 11:59, and then as always, quiz for week 1 of EO7 is going to be Friday from 9 a.m. to 1 p.m. Stay safe and well. Goodbye.